Hey, thanks for tuning in to Check This Out Mathematics. And we are currently doing a series of videos on the features of logarithms. And so if you're liking these videos, give me a thumbs up and put some comments down below and subscribe to the channel and check out more videos from Check This Out Mathematics. Okay. All right. Now, what we're going to do now is prove this idea. All right. To prove that if we have c to the log base b of a, we have c raised to the power log base b of a, that's the same as a to the log base b of c. Okay, and so this says that if we have a base here and a logarithmic statement as our exponent here, that we can just drop this argument down and push this base up to this argument here, and this is true. Okay, so we want to, first of all, make a clarification on what you can do to prove this. And so here's what you can't do. This is what you cannot do. Okay? So suppose that you want to prove that c to the log base b of a is the same as a to the log base b of c. Okay, if you want to prove that, and then you say, oh, you know what, I'll just take the log of both sides, and in fact I'll just take the log base b of both sides. So log base b of c of log base b of a, and I'll take the log base b of the other side. Okay, so here was the original statement here. Okay, here was the original statement, and I just took the log base b of both sides, you know, and then I could, you know, when you have a power to a power here, you can just put this down in front, right? So now I'm going to write this as log base b of a times log base b of c. Okay, so this power here can go down in front, and this power here can go down in front. Okay, and so this power here goes down in front, and let's see, I have log base b of a times log base b of c is the same as log base b of c times log base b of a. Hey, that's just the commutative property, isn't it? You know, make it, x times y is y times x. Well, No, I have not proven this to be true. Because when it comes to equality, we have an if-then situation. So if x equals z, then the log base x is the log base z. So if something is equal to begin with, then we can take the log of both sides. And so we are trying to prove this statement here, and then we say it's true, and then we take the log of both sides. Well, if it was true, then why are we trying to prove it? So we're actually saying, we're wondering if this is the same as that. Okay? That's what we're trying to prove. We are trying to prove that c to the log base b of a is the same as a to the log base b of c. We're trying to prove this to be true. We're trying to say that this can become that. Okay? And so and then we go off and we use the property that if something is already equal to begin with, then we can take the log of both sides. That's what we did here. Well, you can't take the log of both sides. You can only take the log of both sides if something is equal to begin with. And so I'm trying to prove that these are equal. So I can't assume that they are equal and then take the log of both sides. Okay? I have to take this and make it become that. That's a proof. Okay, so that's what we're going to do. All right. All right, so let's write down some of the properties that we're going to use to prove this. Okay, so features of logarithms. Features of logarithms. That's what we've all been talking about this in this series of videos. And so one of the features is the change of base. That log base b of x equals the log base a of x, as long as we remember that it was not log base a, it was log base b. The log base b of x is the same as the log base a of x. And so here we are, we're changing it from base b to base a. And we can do that as long as we remember that it was base b to begin with. Okay, so that's one of our features. And then we have this feature, b to the log base b of x equals x. Okay, that's another feature of logarithms, that if we take b and we raise it to the power that makes b become x, then b becomes x. Okay. And then we also have another feature of logarithms, that's the reciprocal. So if we have 1 over log base b of a, that's the same as log base a of b. Okay, another feature of logarithms, that if we have 1 over a log and the base is b and the a is argument, that when we flip it, then the base becomes the argument and the argument becomes the base. Okay, so let's use these features of logarithms to prove this. Alrighty then, check this out. This is going to work. All right. To prove that c to the log base b of a is the same as a to the log base b of c. Okay, that's what we're trying to prove here. All right, so let's begin with the left-hand side and make it become the right-hand side. That's what a proof is. Okay, so I'm going to start with the left-hand side. C log base b of a. Okay. And so now, what I'm going to do is use the change of base. So this is going to become, this is C. And instead of having base B here, I'm going to change it to base C. So we have log base C of A. We have log base C of B. Okay, so I changed the base in my exponent here. Log base B of A is the same as log base C of A, as long as we remember that it wasn't base C, it was base B. Okay? All right. Then we are going to separate this fraction so that we have C and we have log base C of A times log base C. Oh, hold on, that's supposed to be the denominator. Must have done. Okay. And then we have 1 over log base C of B. Okay, so this was our numerator here, and we're saying that's still our numerator, and this is our denominator, and so we're still keeping it down here in the denominator. Okay, so we just kind of separated this fraction. Okay, now then, let's look at our features here. Here it says if you take b and you raise it to the log base b of x, you get x. And so that's what I'm doing here. I'm taking c and I'm raising it to the log base c of a. And so when I take c and I raise it to the power that makes c become a, then c will become a. Okay. So c to the log base c of a is a. Okay. And then, at the same time, let's use our reciprocal property. That if we have 1 over log base b of a, that we can just switch the a and the b here when we flip it. Okay? And so now this is going to be log base c b of c. Yeah. Okay. So here, c to the log base c of a became a, and then 1 over log base a of b became log, that's not a, where's that? That's a c. Okay. Okay, there we go. It's a c right there. See? It's still a c. Okay. And so now then, 1 over log base c of b, the c and the b can switch when we flip it, and so we have log base b of c. And let's see. That was that, and that is now that. Okay. So we did it. That's how you put it. Okay, awesome. All right. So let's do an example of that, huh? Okay, let's see if Mr. Donald can come up with something here. All right. So suppose we have 2 raised to the log base 4 of 64. Some of my favorite examples here. Okay. So this, what does that give us? Well, what is the log base 4 of 64? Let's see, 4 to what power is 64? Well, that's the third power, right? And so this is 2 to the third, and that's 8, right? Okay, and so now I'm saying that we can switch this. We can put 64, and we can put log base 4 of 2. Okay, so over here we had both of them were log base 4, just like the proof says. Log base b on the exponents there. And we switch the a and the c. So we switch the 64 and the 2. Okay. So let's see. Alrighty then. Okay, now what is the power that makes 4 become 2? Well, isn't it that isn't it that the 2 is the square root of 4? Oh yeah. And so what power of 4 becomes the square root of 4? Okay. Log base 4 of the square root of 4. Okay, so how do you make 4 become the square root of 4? What power of 4 is the square root of 4? Well, isn't it 4 to the 1/2 isn't that how it works? That when we have a fractional exponent, the denominator is our root and the numerator is our power here. Okay, so it's 4 to the 1/4. 4 to the 1/2. Okay. All right. So that's what we have here. We have 4 to the 1/2 power gives us the square root of 4. And so that's 64 to the 1/2. And that's the square root of 64. And hey, that's 8. Oh my goodness, it works. Check it out. Okay, so when you have 2 to the log base 4 of 64, and you simplify it, and you get 8. And then if we happen to switch it, the 64 is here, and the 2 is there, then when we work it out, it's also 8. All right. Cool stuff. Logarithms are awesome. Okay. All right. Thanks for tuning in to check this out, mathematics. Give me a thumbs up and comments down below, and subscribe to this channel right there. And that sums up our features on logarithms. And thanks for tuning in. Mr. O'Donnell signing off.